So another video for you guys. Going to write polynomial least degree again that has following roots, and we have two examples. And the reason this is a little bit different is because we have, in the first example, a irrational root that we're going to deal with, and then down here in example 2, we have an imaginary root to deal with. And they're both basically dealt with the same way. Just want to kind of go through those steps and what it looks like. So the trick's not super duper hard. So we're going to start again by creating our factors from these roots. So I can kind of quickly do that. So I know that x equals -2 has a factor of x plus 2. I know that x equals 0, and that's kind of special actually. X equals 0, because 0 is the root, then the factor is just x. So I'm actually going to put that in the front here. It's the only time I'm going to go out of order. And then positive square root of 3. So what that kind of looks like is like this. X equals the square root of 3. So when I subtract that on both sides, I get x minus square root of 3 equals 0. And so I'm going to put that over here as my factors. Now, the trick here when dealing with these irrational roots is that if we were to multiply this now, we would get irrational coefficients, and that can't happen in a polynomial. So what we do is say to ourselves, well, we're never just going to have one square root. There's always going to be two. There's always going to be the positive version of it and the negative version of it. And this is because if we think about solving a polynomial from the polynomial and we go through and find all the zeros, if we ever have a square root, we're always doing the square root of both sides of something, which means we'll get a plus or minus symbol. So this is actually only one of the two irrational roots. There's a hidden one, which is actually going to be the negative square root of 3. So essentially the trick is that if we have one of the irrationals, we'll have to have the other pair involved with it. So if positive square root of 3 is an irrational root, then negative square root of 3 also has to be there as well. So I'm going to go over here and actually write down x plus the square root of 3. Remember that this root gives us this factor, x minus square root of 3, and this root gives us this factor here. And those are my roots. That's just a trick. If you have one irrational, you have to have two, and we're going to do the same thing down here for imaginaries as well. Now we just distribute. In my last video, I talked about how I normally distribute left to right unless I see anything special. And actually, what I was talking about was this happening. So because we have irrational roots here, I'm actually going to multiply those two first. And what you're going to see is that the irrational or the square roots here take care of themselves. So if I multiply x by x, I get x squared. X times positive square root of 3 is going to be positive square root of 3x. And then negative square root of 3 times x is going to be negative square root of 3x. And then negative square root of 3 times positive square root of 3 is going to be just a negative 3. Square roots cancel out. And what happens here, and you're going to see this whenever you deal with an irrational root, and you will see with the imaginaries as well, the irrational parts, the square roots here, cancel out. So these two go away. And I'm left with x squared minus 3. And I still have x plus 2. And I still have just a plain old x. And now I'm going to distribute again. And kind of your call, you want to do this. You can go in any order you want. I'm going to go ahead and do the binomials first. So I'm going to leave x alone for now. And I'm going to multiply. So x times x squared is x to the third. X times negative 3 is negative 3x. 2 times x squared is 2x squared. 2 times negative 3 is negative 6. And then finally, just to kind of put this all together, I'm going to distribute the x through, and I'm also going to rewrite in descending order. So x times x to the third is x to the fourth. My next highest exponent will actually be when I do x times 2x squared. That'll give me 2x to the third. And then x times negative 3x to get negative 3x squared. And then x times negative 6 to give me negative 6x. And this is my polynomial of least degree for these zeros. Now again, the trick here was that we start with 3 zeros because you have an irrational. You know there has to be a hidden one, and it's just the opposite of whatever sign. So this is positive square root of 3, so I have to include negative square root of 3. Again, we can just give our function some sort of name. So I can say I'll call this f of x this time. So f of x equals x to the fourth minus 2x to the third minus 3x squared minus 6x. And there we go. So that was the first example. Second example, basically the same thing, except that instead of having a irrational root, we have an imaginary root. And very same way, because i's are technically the square root of something, we just have to include both options. So we have positive 2i here, so the hidden root is going to be negative 2i. So always want to make sure we include those. And then we get our factors. So x minus 3, x minus 2, x plus 8, x minus 2i, and then x plus 2i. And again, we're going to multiply the imaginary parts first. They'll take care of each other real fast. So x times x is x squared. I'm going to skip over the middle variables here this time. Because when I do x times 2i, I get 2ix, and then negative 2i times x is a negative 2ix, and they'll cancel out. So I just have negative 2i times positive 2i, which is going to be negative 4i squared. And we know by now that I squared is equal to negative 1. So it's really negative 4 times negative 1, which gives us plus 4. So that's the factor we get when we multiply these two pieces. So we still have x plus 8. We still have x minus 2. And we still have x minus 3. And now we just distribute all these together. And it does take a little time. It's tedious more than anything else, but we can do that. So I'm going to go ahead and just go from left to right from now on. So I'm going to have x times x is x squared, but just a little bit faster this time. So x times x squared. X times negative 2 is negative 2x, and negative 3 times x is negative 3x. That's going to negative 5x. Negative 3 times 2, negative 3 times negative 2 is positive 6. So we have that. And then x plus 8 still, and x squared plus 4. So I'm going to multiply my trinomial times my binomial. So x to the third plus 8x squared. Negative 5x times x is negative 5x squared. Then negative 5x times 8, negative 40x. 6 times x is 6x. And then 6 times 8 is 48. If I combine some like terms here, get this polynomial a little bit smaller, we'll have x to the third. And then we have 8x squared minus 5x squared be 3x squared. Negative 40x plus 6x will give us negative 34x. And then just plain old 48. And then that will be multiplied by x squared plus 4. And now we are going to have to distribute all of this. So x to the third times x squared will be x to the fifth. Oh, fifth, not fourth. Excuse me. Oop. Eraser broke on that pencil. So x to the third times x squared will be x to the fifth. X to the third times 4 will be 4x to the third. And then 3x squared times x squared will be 3x to the fourth. 3x squared times 4 will be 12x squared. 34x times x squared will be negative 34x to the third. And then negative 34 times 4 will be, what's that again? Negative 4 times 4. Negative 136x. I'm going to double check that. My mental math is a little rusty. 48 times x squared would be 48x squared. And then 48 times 4 will be 192. So 192. And as long as I make any mistakes, this should be the beginnings of our final polynomial. So I'm going to leave x to the fifth. So I'm combining all like terms. And then I have a 3x to the fourth here. and no other x to the fourth that I see. So I'm just going to write plus 3x to the fourth. I have a 4x to the third here and a negative 34x to the third. So that's going to be negative 30x to the third. I have a 12x squared here and a plus 48x squared there. So that'll give me 60x squared. And then I have a negative 136x plus 192. And again, I'll give this a function a name. I'll call it the g of x function. Why not? So just double check and make sure I got everything here. Didn't miss any terms. So x to the fifth, x to the fifth. We used x to the thirds up to get this. X to the fourth is there. 12x squared created that, and 48 created that. Negative 136x here, and then the 182. And I always kind of do that after I do a longer problem, just to make sure I'm not going to make a mistake or anything. And it happens. This is a lot of tedious arithmetic to do. You're multiplying a lot of things. You're carrying exponents around, negative signs, x's, coefficients. So always good to double check. So this is how we create polynomials from irrational roots and imaginary roots. And there are examples we can do as well. But that's another way of making polynomials. So that's the end of this video. Thanks for watching.